You know, there's a material out there that has totally revolutionized everything from the planes we fly in to the sports we play. It's a true modern marvel. But this wonder material has a hidden and pretty permanent dark side. And today, we're going to break down exactly what that is. So get this. Imagine a material that is 5 times lighter than steel, but just as strong. That one fact right there is why carbon fiber has become one of the most valuable materials on the planet. I mean, this isn't just a small improvement. It's a complete game changer for how we build things. And chances are, you've benefited from this personally. In the world of aerospace, when you swap out heavy metal alloys for carbon fiber, the planes get way lighter. And of course, lighter planes mean less fuel is needed, which is a huge win for both the airline's bottom line and for the environment. When it comes to pure performance, though, yeah, nothing beats it. High-octane sports like Formula One and NASCAR, they absolutely depend on carbon fiber. It lets them build cars that are not only unbelievably fast, but also incredibly safe, all thanks to that amazing strength. But hey, it's not just for billion-dollar industries. It's in our everyday lives too. You ever wonder how that new tennis racket gets so much power? Or how that bike feels like a feather when you're climbing a steep hill? Yep, that's the magic of carbon fiber, making things better for all of us. All right, so we've established that this stuff is amazing. But what is carbon fiber exactly? You know, what's the secret sauce that gives it all these special powers? Well, at its core, it's actually pretty straightforward. Just picture a cloth that's woven from these super thin but incredibly strong strands of pure carbon. Then, that cloth gets infused with a really strong polymer. Think of it like a high-tech glue that hardens and locks everything into a super rigid, super durable shape. And beyond just being strong and light, carbon fiber has this whole cocktail of other amazing properties. It doesn't rust or corrode, it won't catch fire, and it's non-toxic. Get this, it's even transparent to X-rays. That makes it perfect for medical devices where doctors need to see through the implant. How cool is that? Okay, this is all starting to sound a little too good to be true, right? I mean, a material this perfect, it's got to have a downside. And trust me, it's a big one. So yeah, what's the catch? Well, here it is. For all its incredible benefits, carbon fiber creates a massive, and until very recently, totally unsolved waste problem. This is the permanent, unseen downside of our miracle material. You see, unlike a plastic bottle you can melt down and reshape, or a newspaper that biodegrades, carbon fiber does neither. It's engineered to last basically forever. So when factories cut out parts, all the leftover scraps just get thrown into a landfill, where they will sit completely unchanged for, well, forever. And here's the real kicker. Even when we try to recycle it with traditional methods, the process just destroys that legendary strength. The recycled fibers end up weak and brittle, making them totally useless for the exact high-performance jobs they were made for in the first place. But this is where the story gets really exciting, because scientists and engineers have been tackling this problem head-on. And now we have some breakthrough science that can finally actually break this stuff down properly. The solution really boils down to 2 key processes. One uses chemicals, and the other uses heat. But they both have the exact same goal: figure out how to cleanly separate those priceless carbon fibers from that tough polymer glue. So first up, we've got solvolysis. You can think of this as the chemical approach. You start by shredding the waste material. Then you dunk it in a special solvent that's designed to literally dissolve the polymer, essentially ungluing the fibers. Once that's done, the pure carbon fibers are separated out, cleaned up, and they're ready to go again without losing those amazing properties. The second method is called pyrolysis, and this one is all about heat. Again, you start by shredding the waste, but instead of chemicals, you cook it at a crazy high temperature inside a low oxygen chamber. The intense heat makes the polymer break down into gas and char, which you can actually capture and use for energy. And what's left behind? The pure carbon fibers, which just need to be purified for reuse. So you might be asking, which one's better? Well, it's a classic trade-off. Solvolysis, the chemical method, is fantastic for keeping the fibers in pristine condition, which means they can be reused in really demanding jobs. Pyrolysis, the heat method, is amazing because you not only get the fibers back, but you also recover energy from the polymer, which can make the whole process cheaper. Now, what's so cool about this is that these new recycling methods are so much more than just a clever fix. They really represent a huge shift in how we think about the stuff we make. The future isn't just about recycling anymore. It's about creating a completely circular system. The ultimate end goal here is to create what's called a closed-loop system. It's basically an economy where waste just doesn't exist. The scraps from making a new airplane wing don't get shipped to a landfill. Nope, they get recycled and become the raw material for a new bicycle or a new medical device. It's a truly circular life cycle from start to finish. And this really points to a much more powerful idea. True innovation isn't just about creating something new and amazing. It's also about taking responsibility for the entire life of that creation and making sure it doesn't end up harming our planet. So when you boil it all down, that's the real lesson here. Carbon fiber taught us something incredibly valuable. The challenge for the next wave of innovators isn't just to invent the next wonder material. The real challenge is to answer this question. As we create these amazing new things, how do we plan for their end, right from the very beginning? That's a question we all really need to start thinking about.